The theory of the explosion of the early universe, known as the Big Bang, has long been a cornerstone of our understanding of the origin of the universe. Everything we see today, from giant galaxies to stars, planets and life itself, is believed to have started from an unfathomable dense space. This tiny rock, smaller than the head of a pin, exploded in a massive event that caused the universe to move, expand and grow over billions of years. Despite the widespread acceptance of the theory, advances in scientific research continue to challenge predictions. The launch of NASA's James Webb Space Telescope, JWST, the largest space observatory ever built, was intended to strengthen the Big Bang theory by providing historical insights into the origins of the universe. But only a year after its mission, JWST's discoveries surprised scientists and revealed possibilities that could change our understanding of the beginning of the universe. One of the most surprising discoveries astronomer Rohan Naidu made while examining the JWST images was that he stumbled upon a galaxy that defied all expectations. This galaxy, known as Glass Z13, is an old and massive galaxy dating back hundreds of millions of years after the Big Bang. This discovery not only pushed the boundaries of what scientists thought was possible, but it also generated excitement and enthusiasm. By observing galaxies from this era, scientists aim to improve our understanding of the universe, including the influence of dark matter and dark energy. Initial expectations for JWST were low, predicting the discovery of some distant galaxies. However, reality goes beyond these predictions, revealing galaxies at massive ages that challenge current models. As JWST continues to collect data, the findings may have far-reaching implications, possibly ushering in a new era of understanding the universe. The incredible discoveries of this amazing explorer reveal fascinating stories of world history and man's quest to unlock the world's mysteries. Scientists and enthusiasts alike are trying to explain these findings by revealing old, massive galaxies from JWST images. Could these massive galaxies be an illusion due to errors in the telescope data? Or is it true? How does it fit into our current planetary models? These questions are beyond scientific curiosity, they challenge our understanding of how the universe as we know it emerged from the chaos of the past. JWST's first observations could rewrite the previous chapters of Earth's history. These chapters are not only about distant times and distant galaxies, but also about our own existence in a vast and ever-evolving universe. As Mark McCarran, a senior advisor for science at the European Space Agency, put it, "You build these machines not to confirm the worldview, but to break it." Indeed, the JWST's observations have been billions of years in the making, yet their impact on our understanding of the universe is only just beginning. The journey to build the JWST began in 1985, with early discussions about what would come after the Hubble Space Telescope, which was still years away from launch. The team behind what would eventually become the JWST recognized that while Hubble would be revolutionary, its capabilities would be limited by its reliance on visible light. In contrast, the JWST was designed to see in the infrared spectrum, allowing it to peer deeper into the universe and uncover secrets from its earliest moments. JWST's purpose became clearer in December 1995, when astronomers conducted the Hubble Deep Field observation. The image of the Earth revealed thousands of galaxies spanning more than 12 billion years of the universe's history, highlighting the need for more powerful telescopes to probe past universes. After more than 2 decades of development and a cost of nearly $10 billion, JWST will be launched on Christmas Day 2021. After extensive testing, the telescope will reach its destination in space. A month later, in July 2022, DEEP will be ready to begin its first year of scientific observations. This first phase, known as the First Revolution, contains powerful events designed to shed light on the mysteries of the past. When astronomers spend hours scanning small areas of the sky in search of ancient galaxies, they expect a small discovery, a better outcome. Hubble's deep field, but they were surprised. Stephen Finkelstein from the University of Texas at Austin, who leads one of the JWST projects, explained that these distant galaxies only appeared after a lot of differences in the data from various projects. However, To the astronomers' surprise, these galaxies appeared almost immediately prior to JWST. The record for the most prominent galaxy was held by GN-Z11, which was discovered at redshift 11 in 2015. Redshift measures the stretching of light due to the expansion of the universe, with higher values indicating greater distance. But since the initial observations of glass, two independent groups, including one led by Rohan Naidoo, have identified glass Z13 at redshift 13, promoting the global project that in their rush to get quick results. Researchers used simple methods to estimate the redshift based on light measurements rather than direct measurements. Although simple, these determinations reveal galaxies that are bright and massive, with stellar masses equivalent to billions of suns, similar to our own Milky Way. The excitement never ends. In the following days, several candidate galaxies emerged from various JWST events, some with redshift values of up to 20, indicating hundreds of millions of years after the Big Bang. These galaxies showed disk-like structures that were not expected to occur in the universe. In addition, another group found evidence of mature spiral galaxies at redshift 10, less than 500 million years after the Big Bang. The growth rate of such massive galaxies defies the expectations of the standard model of the universe known as lambda dark matter. CDM. In order to understand this phenomenon, it is necessary to take a closer look at the forces of the first world. In the moments after the Big Bang, the universe was a hot soup, a thick soup of primordial particles. Over time, as the Earth expanded and warmed, helium and other light elements evolved until the first atoms were discovered about 400,000 years ago. Now, about 100 million years after the Big Bang, conditions are favorable for the formation of the first stars, mostly hydrogen and helium. These ancient stars, larger and brighter than today's stars, turned into protogalaxies under the influence of dark matter. However, the JWST observations challenge this model by showing galaxies that are brighter and more massive than expected. Stacy McGaugh of Case Western Reserve University said the small protogalactic components are not surprising, suggesting that some galaxies are closer, dustier, darker and more distant than before. The need for continuous updates of planetary models. The glass Z13 observation in August 2022 by the Atacama Large Millimeter Array, ALMA, in Chile will double the initial observation. Even using light estimates, ALMA did not detect as much dust as Glaser Z13. This shows that red light bulbs can be removed, says Tom Bay of Goya University, who led the observations. However, ALMA did not detect the galaxy, indicating a challenge in confirming observations made with JWST's higher powers. Rohan Naidoo, one of the scientists involved in this phenomenon, observed, "The good news is that nothing was found. The bad news is that it was not found. Only JWST has the ability to track its findings." The most problematic explanation is that the lambda CDM planetary model needs to be updated. Astronomer Michael Boylan-Colchin showed the magnitude of this potential paradigm shift, saying, "These results are surprising and difficult." One of the most controversial applications is the modification of Newtonian dynamics, MOND. Based on the mass calculations, this feature also explains ALMA's difficulty in detecting Z13 early. About making stars now, said Charlotte Bricker and her colleagues. David Spergel supports this idea, suggesting that higher mass stars are more likely to form due to higher atmospheric pressure and temperature, which may have been influenced by pre-existing magnetic fields. The rapid publication of scientific papers since JWST's initial observations reflects the shift to real-time peer review in platforms such as AR14 and social media. While sharing findings may be faster, there are concerns about making decisions before full peer review. Despite calibration issues and potential recalibrations affecting some results, it is unlikely that all high redshift galaxies observed by JWST will be invalidated. The sheer number of these galaxies suggests that the early universe may be different from what was previously expected. Stephen Finkelstein expressed confidence in the validity of the discoveries, stating, "The chances of astronomers being entirely wrong are slim." Currently, astronomers are racing to obtain spectroscopic follow-ups to confirm the distance of these galaxies, using ground-based telescopes like ALMA and even Hubble. JWST is also being equipped with additional spectroscopy capabilities to verify its findings. The ultimate goal is to determine if the JWST data can be used to probe the past, or if the first stars in the universe formed suddenly. They changed our understanding of the first world. As long as the telescope continues in space, one thing is certain: the discoveries it makes will change our understanding of the universe for generations to come.